Hey guys, it's the review for Spiral 5. Starting off, we're looking at general transformations. Question 1 asks us to take a look at the graph of f of x is equal to square root of x. That's going to have a point 0, 0, 1, 1, 4, 2, 9, 3 is the last one that'll fit on here. And it's going to look like this. That's a review of a graph from Algebra 2, and shouldn't be much of a surprise here. Going by the coordinates here, we're going to take a look at this transformation g of x and see what happens. All right, x coordinates first. I'm just going to go 0, 0, 1, 1, 4, 2, and 9, 3. Okay, I've got to set the inside equal to my old x coordinates, so x minus 1 is equal to 0, therefore x equals 1. X minus 1 is equal to 1, therefore x equals 2. X minus 1 is equal to 4, therefore x equals 5. And x minus 1 is equal to 9, therefore x is equal to 10. Those are my new x coordinates. Now I'm going to take a look at my y coordinates. Okay? Here I know I'm going to multiply by negative 3 and then add 6. So we're going to have 0 times negative 3, this is for the y coordinate, which is 0 plus 6 is 6. So y is equal to 6 for that first point. We're talking about 1 comma 6. Okay, second point, we've got a y value of 1. 1 times negative 3 plus 6 is going to be y equals 3. Okay, that's the point, 2 comma 3. So 2, 3. All right. Next up, we've got a y value of 2. 2 times negative 3 plus 6 is going to be 0. This is going to give me the point 4 comma 0. And then finally, we've got the point 9, 3. So we've got a y value of 3. We've got 3 times negative 3 is going to be negative 9 plus 6 is going to be negative 3. And that's going to be a 10. Sorry, this guy should be at 5, 0, not 4, 0. I was supposed to use the new point, not the old point. So then finally we've got 10, negative 3. So there's 10, 1, 2, 3. My graph looks something like this. And that makes sense based on the negative out front. That's going to flip it, make it steeper. I've been moved 4 to the right and 6 up after flipping over and stretching. Here we're still looking at function transformations. At first I'm going to ask you to find some f values. So we've got f of 2, that's the height of the graph at x equals 2. I'm going to go over to 2, and I've got a height of 1. Okay, f of 3.5. I'm going to go over to 3.5, and that's halfway between a height of 1 and a height of 0. F of 3.5 is going to be 0.5. And finally, f of 1 is a little bit of a trick, because if I take a look at 1, that point doesn't exist there or there. So this point does not exist. That's a non-existent point in my graph. The second part of this asks us to find a graph of g of x, which is based on negative 2 of f of x plus 1. I'm going to take a shortcut. I'm going to say that x plus 1 should be left 1. So for my x values, all my points are just going to be shifted 1 unit to the left. For the y values, I'm going to multiply y values by negative 2. So mult y, that's a y, by negative 2. Okay. Starting with negative 3 comma 0. That's going to shift 1 to the left, and then 0 times negative 2 is going to be 0. so negative 3 comma 0 becomes negative 4 comma 0. Next point, I'll take the top of my parabola part. That's at negative 2 comma positive 1. And if I move that 1 to the left, it's going to become negative 3. And multiplying the y value by negative 2, 1 becomes negative 2. The new point is negative 3 comma negative 2. I'm going to take the other piece of my parabola, which is going to be at negative 1, 0. We've already found that 0 height is going to stay at 0 height. So this one's going to shift 1 unit to the left. All right, the first part of my graph is going to look something like this. That was an open circle, so it's going to stay an open circle. Okay, next piece of my graph is this segment from negative 1 to 1. Negative 1, 1 is my first point. That's going to end up going 1 to the left, and it's got a height of 1. Height of 1 times negative 2 is going to be negative 2. That's going to shift down 1 and then become negative 2. There, okay. On the other side, I've got 1, 1. Same height, so it's going to end up at the same height. Shifting 1 to the left, and then 1 times negative 2 is going to be a point 0, negative 2. And that second one is going to be an open circle based on that open circle there. Okay, now I've got this zigzaggy piece. First part of this is at 1 comma 2. 1 becomes 0 by moving 1 to the left. 2 becomes negative 4. That's going to be somewhere down here. And again, that's an open circle too. Then I've got 2 comma 1. 2 becomes 1 by moving 1 to the left. 1 becomes negative 2. My new point is at 1 comma negative 2. Ooh, I actually missed something. I'm going to go back to f of 1 in a minute. And I'm actually going to erase that thing I just did. So this is my second value, so our graph's going to go to there. My third point here, that looks like 2.5 comma 1.5. 1 to the left is going to be 1.5. Multiply that by by negative 2. We're going to have 1.5 comma negative 3. There's the second part of my zig. And then finally I'll take 4, 0. I know 0 height's going to stay at 0. It's just going to shift 1 unit to the left, giving me the rest of my zigzag. Okay, we have got a steeper zigzag in terms of what's going on here, and it's been shifted a little bit to the left. Finally, let's go back to f of 1 again. So f of 1, I said, oh look, open circle there, neither of those points exist. But if you look way down here, the point 1 comma negative 2 is actually on this graph. So if I find f of 1, what is the height of this graph at x equals 1? Well, I have this extra point in there that has a height of negative 2. So the height there is actually going to be negative 2, does not exist. And finally, we've got to find g of 2 and g of 0. That's going to be based on my new graph. G of 2 is going to be what's the height of my new graph at 2. And looking here, it looks like a value of negative 2. I'm just going to double check that by plugging this into my original thing. So we know g is the graph of negative 2. F of x plus 1. If I want to find g of 2, one way that I can do that is plug that in. So negative 2 times f of, and then 2 plus 1 is 3. F of 3 is 1. And if I multiply 1 times negative 2, I get negative 2 as a value. G of 2 is negative 2. And finally, g of 0. I'm looking for my new graph at x equals 0 that has a height of negative 2. G of 0 is negative 2 also. If I wanted to plug that in, g of 0 is equal to negative 2 times f of 0 plus 1 is 1. f of 1 had a value of -2. Ooh, this is going to be interesting, actually. So this is not correct. So f of f of 1 is a value of -2. That's that weird point we found earlier, which means that g of 0 should have a value of 4. Ooh, that was fun. And that doesn't show up on my graph. That would be way up there. That was a pretty cool problem. Lesson learned, it's a good idea to plug these values in as well as just try to graph them. Here we're being asked to solve an entire triangle. This is a right triangle, so we can use SOHCAHTOA for that. One of the dangers that I've noticed on the last spiral is that everybody seems to be trying to use law of sines and law of cosines to solve some right triangle trig problems. To my friends who are in the room currently taking the spiral I'm talking about, you can use SOHCAHTOA if it is a right triangle. Hint, hint. That's also a hint for you, my friends, who are completing the spiral review. Okay, I know that this third angle is going to be 44 degrees because this is going to be 46, and to get to 180 I need 44 there. Second part of this is I'm trying to find, I don't know, let's go for BC first. Maybe use angle A for one reason. This is going to be my opposite, and I have my hypotenuse, that's going to be sine. So sine 44 is equal to A over 13, and if I multiply both sides by 13, 13 times sine of 44 should give me my answer, and that's going to be an angle, or a side of A equals 9.0305. That's part of this. Next thing I could do if I want to find that third side, instead of using more trig, I could Pythagorize and write 9.03 squared plus question mark squared is equal to 13 squared. So that's going to be 169, which is 13 squared, minus 9.03 squared. And that's going to be 87.4591 is equal to question mark squared. Square root both sides, we only want the positive one because it's a length. And I get a value of 9.35. So I have now solved my triangle. I found all sides and all angles. Next up, we've got a problem. We've got to find the height of the building to the nearest foot. I could set this up as a system of equations where this, let's call it h for height, is going to be a right angle to these two triangles. So I've got a smaller triangle. That's 48 degrees. We've got h. And then I've got a question mark and a question mark here. Maybe call this, I don't know, I've already got an h for height, so maybe a y for hypotenuse and an x for, well, x. Then I've got a bigger triangle, which is this guy, where I've got 35. I've got another h, and this is going to be 150. And then plus x, because that's that extra point there. See, x for extra. I am so witty. And in setting this up, I might say that tangent of 48 is equal to h over x. That's based on this guy here. In other words, x is equal to, h is equal to tangent of 48 times x. My other one's going to be tangent of 35 is equal to h over the quantity 150 plus x. Scrolling, scrolling, scrolling. In other words, tangent of 35 times 150 plus x is equal to h. Both of these happen to be equal to h. So I could rewrite that as tangent of 35. I'm going to do some decimals now. Is 0.7002, so I'll call that 0.7 times 150 plus x is equal to, and then on the other side, tangent of 48. Tan 48 is 1.11x. Do some distribution. 0.7 times 150, 105 plus 0.7x is equal to 1.11x. 105 is equal to 1.11 minus 0.7 is going to be 0.41x divided by 0.41, so 105 divided by 0.41, and I get x is equal to 256.09. Unfortunately, I don't really want x, I want h. So 256.09 or 0.1. Okay. But I know that tangent of 48 is h over x, so that was 1.11 is equal to h over 256.1. Do some multiplication. 1.11, and I get 284.268 is the height of my building, or h. Woo! That was exciting. All right, number 3, we're looking at, I don't even know this is real number 3, I think this is real number 5 or something. We've got to make our own triangle because I don't give you one. Let's call this triangle A, B, C, and be all original and stuff. Angle B is 54, angle C is 61. When I do 180 minus 54 minus 61 to get that third side, I get 65 as a measure of angle A. Side A is 28, and I'd like to find side C. Okay, not a right triangle. I cannot use SOHCAHTOA. Do not fall into that trap. I do, however, have some opposite information going on here. That makes this a great case for the law of, you know it, sines. So we've got sine 65 over 28 is sine 61 over c. Sine of 65 divided by 28. Making sure I don't accidentally divide before I do the sign. I get 0.323. Sorry, 0.0323 is equal to sine of 61, 0.8746 divided by c. Multiply both sides by c and divide by 0.0323. I get c is equal to 0.8746 divided by 0.0323, which is 27.078. All right, next one, I'm not told what to find, so let's find everything. Here I've got a couple sides and an angle. I don't have enough information to use law of sines. Nothing is going to match up in terms of going across any of these. So for this, I'm going to use law of cosines. First, I'm going to find AB, and maybe I'll call that a day at that point, because all these end up being pretty similar. So c squared is equal to a squared plus b squared minus 2ab cosine c. Plugging stuff in, c squared is equal to 17 squared plus 25 squared minus 2 times 17 times 25 times cosine of 96. I'm going to quite literally plug that into my calculator. 17 squared plus 25 squared minus 2 times 17 times 25 times cosine of 96. Press enter, and I get that c squared is equal to 1002.849. And then I have a freak out moment realizing that 1002 doesn't make sense, and then I come to my senses because I realize that's a squared. I need to square root both sides. Square root, and I get c is equal to 31.66, and that sounds a lot better. Next up, we got to sketch some angles and some radians. Negative 20 degrees means I'm going clockwise, and I'm going to start at the positive x-axis. That's where I always start. And 20 degrees is going to be something like that. I know it's between 0 and 90, so that's why I chose that. Two coterminal angles. Well, I could add 360 and get 340 degrees. That's coterminal. If I wanted, I could add another 360, and I get 700 as a coterminal angle. These are my two coterminal angles. I could also add another 360 or 3600, any multiple of 360 that I desire. And I think I made individual slides for each of these. Let's make use of them. All right, 17/12. So here's how I'm going to take a look at this. I'm going to write everything in terms of pi's over 12. So I know this is 0 pi over 12. This is pi over 2. If I write that in terms of pi over 12, I could say that's 6 pi over 12. It's like I'm unreducing fractions. I know this guy is pi. That would be 12 pi over 12. I know that down at the bottom is 3 pi over 2. If I multiply top and bottom by 6, I get 18 pi over 12. And 17 pi over 12 is going to be right before that. So we're starting at our positive x-axis, and we're going like this. If I'm adding and subtracting 360 or 2 pi to this angle, so 17 pi over 12 plus 2 pi would be one coterminal angle, which is going to be 17 pi over 12 plus, and 2 over 12, it's going to be 24 pi over 12. That's the unreduced form. And 17 plus 24 is going to be 41 pi over 12. I could add another 24 pi over 12 to that, and I end up with 65 pi over 12. Those would be two coterminal angles, and I'm adding 2 pi to each of those values. Here we're trying to find the reference angle for this angle. We know that the reference angle is referring to the angle between our value and the x-axis. So the first thing we're going to try to do is figure out exactly what's going on here. I know we're going around one full time and then some extra. So what I might do is try to figure out what this version of this angle is by just adding 2 pi to this until I end up a little bit positive. So 61 pi over 18. I'm going to add 2 pi to this and see what happens. That's going to be 36 pi, so negative 61 pi over 18 plus 36 pi over 18. 36 minus 61 is going to be 6, minus another 30 is negative 24, minus another 1 is negative 25 pi over 18. Still not positive. So I need to find another coterminal. So I'm going to add another 36 pi over 18, and that's going to end up being 11 pi over 18. Okay, so now I figured out this guy here, which is 11 pi over 18. To figure out how much is left to get down to pi, I could just subtract those two. So if I find pi minus 11 pi over 18, that should tell me the difference between pi and that angle. Okay? 18 pi over 18 minus 11 pi over 18 is going to be 7 pi over 18. As an alternative, if you wanted to convert this to degrees instead of radians, 7 pi over 18 is our answer, by the way. You might do something like this. Okay, negative 61 pi over 18 times 180 divided by pi. My pi's cancel. 18's cancel. So that's going to be 10. And I'm going to get negative 61 left. Negative 610 degrees. I'm going to add 360 twice to this. So I'm going to add 720. And when I do that, I get 110 degrees. Okay? So I know that 110 is like there. To get down to 180, I need 70 more. this reference angle would be 70 degrees, which is the same as 7 pi over 18. One, you have to deal with fractions and deal with subtracting things with pi. The other, you got to do a conversion. Both of those are correct for this problem and the way it's asked. Our next problem, we got to convert this from degrees to radians. And doing that, we're going to look at 190. I know to get from degrees to radians, I need to add a pi in. And if I'm adding a pi, I've got to divide by 180. Okay, this is 190 over 1. My 10s cancel out, and I'm left with 19 over 18 pi. At this point, I am done. For our next one, we're converting from radians to degrees. I've got 14 pi over 9. I know I need the pi's to cancel out, so pi is going to be on the bottom. And that means that 180 is going to be on the top. You could also do this with 360 or 2 pi. You get the same values. My pi's cancel. I can also reduce 180 divided by 9 is going to be 20. So I've got 14 times 20. 14 times 20 is going to be 280. And that's my final answer. Now we've got some unit circle trig stuff. I need to start with tangent of pi over 6. And I'm going to treat this as though we're using special right triangles as our method. First thing I'm going to do, just to save me the trouble after, is identify where my angle is. And in the first quadrant, all trig values are positive. So I know I want a positive value for tangent. Okay. Second step, anything pi over 6 is going to be the pi over 6 family. That means a 30, 60, 90 right triangle. So there's 1 root 3 over 2 and a half. Tangent of this is going to be opposite 1/2 divided by the root 3 over 2, which I can rewrite as a divide. 1/2 divided by the square root of 3 over 2, which is 1/2 times 2 over the square root of 3. Those cancel and left with 1 over the square root of 3. That's my final value. If I wanted to simplify this to eliminate the radical in the denominator, one thing that I could do would be to take 1 over the square root of 3, multiply it by root 3 over root 3, and I get the square root of 3 over 3. That's also an acceptable answer. To find sine of 135, this one I'll do as a unit circle problem. I'll draw a really awesome unit circle. 135 is there. Now I need to figure out what coordinates are there. First thing I do is figure out my reference angle. To get from 135 to 180, we're looking at a 45-degree reference angle. Okay. That means my coordinates here are going to be the negative square root of 2 over 2, comma the square root of 2 over 2. The one above this would be negative 1/2 root 3 over 2, and the one below this would be negative root 3 over 2, comma 1/2. Since we are looking at the sine is the y value. We use the y value of my angle here, and that's going to be the square root of 2 over 2. Tangent negative 60. I'm going to do this using triangles to help. First thing I'm going to do is locate this. Negative 60 is going to be in the fourth quadrant. I know that in the fourth quadrant, only cosine is positive because the coordinates are positive and negative. I don't know why I put a 1 there. Tangent is y divided by x, so negative divided by positive is a negative value. Okay, that's my first step. 60 makes this an easy choice for a reference angle. I'm going to use a 60-degree special right triangle. So root 3 over 2 and a half. Tangent is opposite divided by adjacent. So it's root 3 over 2 divided by a half. I already wrote this horizontally to make this a little bit easier. Root 3 over 2 times 2 over 1, which is root 3 over 1, or the square root of 3. Cotangent of negative 3 pi over 2. Okay, first thing I need to know is that cotangent is the reciprocal of tangent. So I'm going to make a goal to find tangent of negative 3 pi over 2 and flip the result. Okay. I'm going to do this using unit circle. So if I'm looking at negative 3 pi over 2, well, there's negative pi over 2, negative pi. Negative 3 pi over 2 is up here. I know that the coordinates here are 0, 1. Tangent at this place would be 1 over 0, y over x. Because we're doing cotangent, we got to flip that. So cotangent at this point is going to be 0 over 1, which is just 0. Looking at sine of negative 7 pi over 6, I'm going to do this using some triangles. First thing we do is locate this. Negative 7 pi over 6, that's a little bit more than negative 1 in terms of rotation. So there's negative pi. So that's pi, otherwise known as negative 6 pi over 6, going backwards. Up here would be negative 3 pi over 2, or if I want to convert that into 6 as a denominator, so times 3 over 3, we get negative 9 pi over 2. Okay, my angle is going to be somewhere in here, and this is in the pi over 6 family, so we're looking at a 30-degree angle. I know that in this quadrant, only sine is positive, and that's because the y values here are positive. So we're looking for a positive version of our trig value. Okay, so 30, 60, 90. My 1/2, 1 root 3 over 2. Sine is going to be opposite, divide by hypotenuse. I get a value of 1/2. It needs to be positive, so that can be my final answer. Looking at cosecant of 2 pi over 3, I'm going to do this using unit circle methods. First thing I need to know is that cosecant is the reciprocal of sine. Okay, so my goal is going to be find sine of 2 pi over 3 and then flip it. All right, 2 pi over 3 is going to be in the second quadrant. It's more than a half and less than 1 pi. And in fact, it's going to be the top of those three angles, because here I've got 5 pi over 6, 3 pi over 4, and 2 pi over 3. Pi over 3 is always going to be the upper or lower angle as far as those families go. My coordinates there are going to be negative 1/2 and positive root 3 over 2. For sine of this value, so sine of 2 pi over 3, I choose the y value because sine is y. I get root 3 over 2. For cosecant of 2 pi over 3, I'm going to take the reciprocal of that, which is 2 over the square root of 3. I could leave it like that. That's totally fine as an answer. Or I could rationalize the denominator by multiplying by the square root of 3 over the square root of 3. And I get 2 square roots of 3 over 3 as an answer.